本日はお忙しい中お集まりいただき誠にありがとうございます。
Thank you for taking
ただいまより
time out of your busy schedule to join us today. I'd like to now begin the joint press conference by Idemitsu Kosan and Toyota Motor Company. Today's MCs are Kato of Communications Department of Idemitsu Kosan and Eri of Communications Department of Toyota Motor Company.
I
would like to invite the speakers to their stage. From Idemitsu Kosan, we have with us Mr. Shunichi Kito, President and Representative Director. And from Toyota Motor Company, Mr. Koji Sato, President and Representative Director. First, I'd like to hand over the microphone to Mr. Sato of TMC. I'm Koji Sato of Toyota Motor Corporation. Thank you very much for coming today despite your busy schedules and the short notice. Idemitsu Kosan and Toyota Motor Corporation have agreed to collaborate on the mass production of solid-state batteries. Specifically, our two companies will combine the separate efforts to mass produce new materials and establish a supply chain for solid electrolytes, which hold the key for the practical application of solid-state batteries. First, between 2027 and 2028, we will start to produce solid-state batteries for use in battery electric vehicles. We will then lay the foundation for mass production. Let me explain about the background behind this collaboration. To emphasize our company's stance, battery EVs are an important option in Toyota's multi-pathway strategy. For the next generation batteries that will support the evolution of battery EVs, we are developing optimal solutions in line with the specific applications and characteristics, including high output and long-range batteries, as well as high-quality and affordable versions of widespread use. And looking ahead to the future of battery technology, we are developing solid-state batteries as an option beyond liquid batteries. An advantage of solid-state batteries is that the electrolyte is solid. This allows ions, which convey electricity, to move faster, and thus enabling shorter charging times, increase the cruising ranges, and higher power output. The solid-state batteries are also characterized by being highly stable because they are resistant to changes in temperature and can robustly endure high temperatures and high voltages. In addition, as solid-state batteries are smaller and more powerful, they will enable battery EVs to meet a diverse range of needs, from sports cars, which require high-power performance, to commercial vehicles, which require frequent quick recharging. On the other hand, the biggest challenge is durability. A long-standing technical issue has been that repeatedly charging and discharging the battery causes cracks between the cathodes, anodes, and the solid electrolytes, degrading the battery performance. Since 2013, a partner in working together to solve this issue has been Idemitsu, which was one of the first companies to conduct the development of elemental technologies for solid-state batteries.
The one such elemental technology is a highly flexible, adhesive, and crack-resistant solid electrolyte. Through repeated trial and error, and by combining the material technologies of both companies, we have been able to develop a crack-resistant material that demonstrates high performance. By combining this new solid electrolyte with the Toyota Group's cathode and anode materials and battery technologies, we are now on the path toward achieving both performance and durability in solid-state batteries. The key theme for us going forward is mass production. First, our two companies will together address the quality and cost aspects of solid electrolytes. We will then proceed with verifying mass production by using Idemitsu's pilot facility and establishing a stable raw material procurement scheme. To steadily move subsequent market introduction forward, we will establish a task force of dozens of people, including those from technology, procurement, logistics, and production technology, and we will jointly promote our efforts. We will also combine our two companies' materials development technology, Idemitsu's material manufacturing technology, and Toyota's battery mass production technology in a full-scale effort to mass-produce solid-state batteries. For the beginning of the manufacturing phase, the important thing is power of realization. Idemitsu, with its corporate vision of shaping change, positions the power of realization at the center of its corporate management. Toyota, as well, is committed above all else to embodying its vision in its vehicles as it transforms into a mobility company. I believe that our two companies working together will multiply many times over our power of realization. When I first met President Kito, I learned of his strong desire to act with will to change the future of energy. That's exactly how I feel. As we have conveyed through our Toyota mobility concept, Toyota believes that the key to changing the future of cars is a collaboration between the automotive and energy industries. Our two companies will unite their strengths to mass-produce solid-state batteries and to realize innovations originating in Japan. We will create the future of mobility together. With this at heart, we will take on challenges and hope that you will look forward to what we will achieve.
Thank you very much. Next, I should like to invite Mr. Kito, President of Idemitsu Kosan. I'm Shunichi Kito of Idemitsu Kosan. Thank you so much for taking the time to join us today. As President Sato just mentioned, it is not potential or dreams, but the ability to realize them that is being put to the test. Idemitsu will support Toyota's ability to realize the commercialization of solid-state batteries for battery EVs with technological strength through manufacturing and mass-producing the solid electrolytes used in such batteries. The target for commercialization is 2027 or 2028. It means that the commercialization of solid-state batteries is a thing of the future that is now within reach. Let me explain why Idemitsu is working on solid electrolytes. This collaboration targets sulfide-based solid electrolytes. We are confident that sulfide-based solid electrolytes are the most promising solution for battery EV issues such as cruising range and charging time. These electrolytes are made from sulfur components generated when manufacturing petroleum products. They are byproducts of improving petroleum products. Idemitsu discovered the usefulness of sulfur components in the mid-1990s, and through our research and technological capabilities cultivated over many years, we have succeeded in creating a solid electrolyte. The solid electrolyte is about to open up a new future for mobility. Idemitsu is making every effort to implement a wide variety of materials, energy, and resource circulation solutions toward realizing a carbon-neutral society.
With our existing infrastructure networks of service stations, refineries, and business offices throughout Japan, our initiatives are built on the knowledge and technology we have developed through our fossil fuel business. In our medium-term management plan announced last November, we presented several items for social implementation to achieve a carbon-neutral society, with initiatives for a solid electrolyte business being key among them. While looking to the future of the global environment, we support people's lives by stable supplying with essential materials and energy. That is Idemitsu's mission. The future of energy and Toyota's multi-pathways, which consider the reality of each region and keeps Toyota close to its customers. We share the determination and desire to lead the way toward a carbon-neutral society, promoting decarbonization while protecting people's livelihood is not something that can be achieved through the efforts of individual companies. Toyota Motor and Idemitsu Kosan will bring our technologies together to realize the commercialization of solid-state batteries. It is also our aim to make the technology obtained through this collaboration a global standard. This will demonstrate to the world the high level of Japan's technological capabilities. Changing the future of cars also means changing the future of energy. Changing the future of energy and mobility can greatly contribute to protecting the global environment and realizing a sustainable society. With this belief and determination, we will move forward. I believe that this collaboration is our first step toward giving shape to change, together with like-minded colleagues. Please look forward to Toyota and Idemitsu taking on this challenge.
Thank you very much, Mr. Kito. From now on, we'd like to move on to Q&A. And now to the two speakers, you can step down from the stage for now. And during the Q&A session, questions in English will be translated consecutively. Please be patient because we are now rearranging the stage. The questions in English during the Q&A session will be translated consecutively.
ただいまより質疑応答を始めます。
I'd like to now begin Q&A session.
まずはじめに登壇者をご紹介します。
I'd like to take time in introducing those on the stage. From Idemitsu Kosan, we have with us Shunichi Kito, President and Representative Director. From Toyota Motor Corporation, Mr. Koji Sato, President and Representative Director. From Idemitsu Kosan, we have with us Mr. Hajime Nakamoto, the Senior Managing Executive Officer, and from Toyota Motor Corporation, Keiji Kaita, President of Carbon Neutral Advanced Engineering Development Center.
ここからは着席で進行させていただきます。
Now, please allow them to take a seat. Now, please take a seat on the stage.
ここから皆様のご質問をお受けします。
Now, we'd like to
なるべ
take
く多くの
questions.
方からご質問をいただける
We'd
よ
like to
う
take
大
as
変
many
恐縮です
questions
が、
as possible,
お
and
一人様
therefore,
一問のご質問でお願いしたいと
we'd
存
like
じ
to
ます。
limit the question asked by one journalist would be limited to
会社名、お
one.
名前をおっしゃって
Please wait for the
ご質問
microphone
をお願いい
and
たし
then
ます。
state your question and affiliation.
それでは会場
And
の皆
please
様、
limit the number of
マイクを
questions
お持ち
to
いたします
one.
ので、挙手をお願い
Now,
いた
please
し
raise your
ます。
hand and wait for the microphone.
ではこちらの一番前の方、お願いいた
Yes,
します。
a person on the front row.
産経新聞の池田と言います。
池田 of Sankei.
先ほどの説明
Earlier in the
の
presentation,
中で、紀藤社長が
I think Mr. Kito
世界の
mentioned
標準として展開したい
that
と。
the intention is to eventually deploy it as a global standard. And in conjunction with that,
今回のその材料の
about the material that is going to be developed jointly and for mass production, what about the IPs? What is the handling of intellectual properties? Because I would assume that both companies have a large number of patents. Is it going to be handled as a cross-licensing? I'd like to know how you're going to handle IPs held by each company. And with that, if you are to achieve a global standard, then on the part of Idemitsu, you'd like to see that this material be widely introduced into the market. In that case, for Toyota, their technology, a competitive edge, might be also introduced together and shared. So what could be the timing of introducing such a product, and what about the timing of the transferring that the product or material to Toyota TMC? If you can tell us how you are planning to do that. Mr. Ikeda, thank you for your question. I am Nakamoto of Idemitsu Kosan. Allow me to answer your question. As you pointed out, yes, in fact, in terms of patents, as you have seen, for sulfide electrolyte, which made from lithium sulfide, as you see, both Toyota and Idemitsu have the largest number of patents. And of course, there are other Japanese companies that hold patents for those technologies. But taking a look at this, this points to the competitive advantage of those two companies. And what about the future? Of course, it is up to the negotiation and discussion between Toyota and Idemitsu. For now, the EV that is equipped with the sulfide-based the electrolyte battery, the all-solid battery, it doesn't exist except for a demonstration. But EVs with the solid-state battery to be introduced into the market by Toyota. What we need to do first is to demonstrate its quality and performance, and then that will be evaluated by Toyota, as well as battery and technology would be evaluated duly. Therefore, for the time being, together with Toyota, our aim is to realize this. And as was explained earlier, this is a combination of the leading technologies from Japan, and therefore we as partners are going to work on this, and eventually in the future, we would like to realize that this technology is recognized as a de facto global standard. And for that, we hope that we can gain understanding mutually each other. And allow me to supplement what was mentioned, Kaita speaking. As to the candidate materials, the substance patent is held by Toyota, but just having such a patent does not lead to production. In fact, expertise and technology is held by Idemitsu. And Chairman Toyoda and President Sato have been always insisting on the following point. That is, we have to consider the widespread of environment-friendly technologies, and that's another area that we'd like to work together so that this would contribute to the society and to the world. Thank you.
すみません、整理します
Thank
け
you
ど、
very much. Let me
じゃあ
sort
当
it
面は
out. So
両
for
社
a
間
while, the both companies, two companies will dedicate your efforts, and you only supply to the TMC's EV for the time being. But in the future, sometimes both companies will talk together to achieve the de facto global standard. Is that the right understanding about timing? Yes.
池田様ありがとうございま
Thank you,
し
U.S.
た。
Mr. Ikeda.
ではですね
So we'd like to entertain the
こちら
next
の
question.
前から3列目の
On the third row, the person wearing a black jacket, please.
日本経済新聞の富山です。
富山
よろしくお
日本経
願いします
済新聞 Thank you.
今回のですね、
For
取り組み
this
で技術的
initiative,
な
that
ですね、ところをちょ
technologically,
っと教えていただきたい
I
んですけ
have
ど、
some
先
questions.
日豊田さん
Because
が
the
です
other
ね、
day
ブレック
TMC talked
全
about
国大会記念日で技術的なブレイクスルーがあったという話があるんですけど、
breakthrough for
前
solid
回の発表と今回のイデミスさんの提携というのはどの程
state
度関
battery,
係
but
しているのか
how
という
was
とこ
that
ろと、
relevant
あと
to
その
this
今回です
time
ね、
announcement
一緒
of
に
the
協業
collaboration
する
with
というこ
Idemitsu
とで、
that you
これはその
collaborate together?
その豊田さんの陣営にイデミスさんが入るというふうに見
The
えるん
group
ですけ
that
れども、
maybe Idemitsu
これ
will
はその
join in
共同開発技
Toyota's
術というのは、イデ
collaboration.
ミスさんは他
So
にも
the
OEM
collaborative
との
work,
取引もあ
I
ると思うん
think
ですけど、
Idemitsu
そこら
has
辺はどのようにな
other
っていくんでしょう
transaction
か。
with OEM. So how will you sort out that relationship? First of all, I'd like to respond to the first part of the question and to Toyama-san, and Kaita would like to answer this part. Earlier, yes, we said we had a discovery of the breakthrough achieved. Actually, this in order to really release it in the society, there are three major technology we do need. And then all that, I think one of the important elements is this Idemitsu now collaboration. That is one important element or pillar. Because battery, I think you have to purchase from the material supplier and you assemble and then you develop further, but that's not enough. You have to find new material, create new material. So as a battery company or from automotive companies, we all have to be involved and then together work in-depth collaboration. So that we talked about but in the collaboration, I think we have to come out with new ideas and discoveries to further evolve and develop this technology. So in that sense, aside from that, there are other key technologies, important factors here. But in order for SE to become the major piece, I think this collaboration will ensure this success factor for one of the most important components. You said three components, one of the three component technologies. Could you please be a hint for some more, a bit more details if you can disclose? Basically, for this all solid the battery has a high performance, which I'm sure everyone agrees to. However, as President Sato mentioned, that the crack is likely to happen to that kind of a solid-state battery, and there are many factors which cause the cracks. For example, this is maybe this AC might be disassembled, or maybe the cathode, the anode, the surface might become detached, or maybe there will be some shrinking or this an expansion of the battery per se. So according to each factor, I think you really have to cope with each issue one after another. So that the key technology is this one, as I mentioned, that we will collaborate to develop. Thank you.
はい、 ではですね、真ん中の列の
Now then,
すみません、あと中本さん
ごめんなさい。すみません。ごめんなさい。
後半のご質問。
for the second part of the question, if Mr. Nakamoto
2番目
can
の方のご質問
add some explanation
これも
about the
先
second
ほど
part of the
IP のところの
question.
ご質問がありましたけ
Well,
れども、基本的に
earlier
は
there
それ
was a
と同
question
じような
about
形で
IP, and in fact, it will be treated in the similar way. That's how we're going to handle the
それ
technology.
で回答になってますでしょう
Hope
か。
that this answered your question.
そのトヨタさんと共同開発した技術というのはじゃあ他の
The
OEM には基本的に
outcome
は
of the
渡ら
joint
ない
development with
また
Toyota will not
別々のそれ
be
ぞれ開発していく
introduced into other OEMs. In other words, there will be separate
両者
the
で作っ
development
たものは
project
やはり両
for
者
those
が
that were
納得
developed
した上でどう
jointly.
いうふうにする
And
か
then
ということを話し合って
the
いく
both
わけで
of
ご
us
ざいま
have to
して
decide, discuss and
今後
decide what to do with that. So it is all up to the dialogue between Toyota and us in deciding what to do or how to handle it. And about other OEMs, what we're going to do, the soft and adhesive material that Mr. Sato mentioned, that's one characteristic. But in addition to that, we have other materials as well. Being a material producer, we have more solid or hard type of the material as well. And we are actually producing such a material, and therefore the materials that we can offer, that will be multiple. Hope that this answered your question. Thank you.
ありがとうございました。
Thank you.
では真ん中の扉から2列目
So
の
on the second row and then the fourth low row as well, that the person wearing a blue shirt. I'm Tsukaoka Nisuke Cross I have a simple question. At present, right now, unfortunately, Tesla or the BYD are really leading this EV market share. However, in this, if the all-solid-state battery will become commercialized, maybe you will reverse this the leadership. Will that become this strong strength for you to defeat them? And when do you think that this will be used? Percentage of utilization all-solid-state battery in the future, and then because it will really show the bright future of this new technology. Thank you very much for your question, Tsukaoka-san. Sato of TMC would like to respond first. So in your presentation, we also covered about this all-solid-state battery technology will important element to build the strength of this battery diversified capability. But final users, when they buy the vehicle, how will the total appeal of that vehicle, the product, that will finally determine the final the benefit and advantage of a product. So the battery alone cannot decide the overall vehicle attractiveness, because cruising range or the charging performance is not all. Battery EV should give additional value to that. How can we do that? Software-defined vehicle will have added value, and we should really accumulate that as well. In energy management-wise, we should have an in-depth improvement of the vehicle as a mobility, so that the vehicle will become more attractive as a mobility means. So the total comprehensive product appeal should be enhanced. That's the important point we like to emphasize. When and how much the percentage of that utilization? To respond to the question, that initially that maybe this lab-based the research and development, we now have a certain surety. In other words, we have to now overcome the challenge of this commercialization. In that demonstration pilot plant of the Idemitsu, we would like to achieve the stability, and some of the parameters will be studied and researched, and we accelerated that R&D effort in that pilot project. But as mentioned, in 27 or in 27, at the beginning of 28, we would like to deliver this to the society. So we would like to accelerate these R&D efforts. However, the battery technology and production technology has to be economically feasible in a way. In other words, before that stage, that there's a certain steps, very important steps before that the large scale the production level. So that the first step is that you really have to deliver the product to the society and to the users, and then mass production should be achieved by increasing the volume. So that's the second step as well. So it's a stepped approach. So at the beginning, at the startup phase, the volume might not be so huge. However, first specifically, we will deliver as the concrete product to the society. That is the most important focus for the time being. But later on, that we will expand the scope, the volume. That is the steps that we like to follow.
はい、よろしいでしょうか。
ありがとうございます。
はい。それでは
Thank you very
ですね
much.
真ん中の列の
And then
4番目の
The fourth from the front in the middle
メガネの
row, the person with the white shirt with
科
glasses.
学工業日報の井上と申します。
Inoue is
本
my
日はあり
name.
がとう
I'm
ござい
from
ます。
Kagaku Kogyo
私からはです
Nippo
ね、Idemitsu Kosan
Chemical
さんに
Industry Daily.
どういった
I have a
強みを
question
今
to
回の協
Idemitsu.
業の中で
In the
発揮してい
collaboration,
けるでしょうか
what
という
kind
点に
of
ついて
competitiveness you can demonstrate in this collaboration?
主にですね、原料供給面と
The
技
raw
術面
material
の2つ
supply
で
as well as
強みをそれぞれ
technology.
発揮されるのではないかなと
I
思います
assume
けれど
those
も
are two areas where
原料
you
については
want to demonstrate your
原料の一つの
competitiveness.
硫化水素が
And
石油生成事業の
The hydrogen sulfide, that's a byproduct of the oil production process that could be retained at the same time. You might need a lithium hydroxide. In that case, you are making investment into the European company in this respect, but eventually you would also consider securing the supply of lithium. And in terms of technology, you have been working on this project for many years. In terms of studies, if you can tell us more specifically about the strength that you have developed, so the material or the substance supply as well as the technological strength.
井上様ご質問ありがとう
Thank you very much, Mr. Inoue, for your question. Nakamoto is speaking. I'd like to respond to your question, and I'd like to show you a slide.
これが私どものですねマテリアルフロー
This is the material flow.
でご覧いただきました通り
As you
ご質問
see,
いただいたこともあるんですけど
And as you rightly pointed out,
私どもオーストラリアの
In Australia,
リチウム鉱山に対しての出資を
we are making investment into the lithium producing mines in
ここから出
Australia.
てくるものが
And
水酸化リチウム先ほど
There we receive supply of the lithium hydroxide. And then in a refinery, there are 7 of them in Japan. And then as a byproduct, we will get a sulfur component. When those two are combined together, mixed, and then we will get intermediate material, which is the lithium sulfide. And then other substances, materials would be added together to produce solid electrolyte. The aim of the joint project with Toyota. For solid electrolyte pilot plant, we plan to start operation in 2027. Green Innovation Fund from the national government is expected to be received, and with that, automatically that means the lithium sulfide production facility would be also introduced. At right timing, we will make such a decision. What to do with the lithium sulfide that's in the middle, the final decision is yet to be made, but this is something that is considered to be quite promising, and therefore that's what we are currently considering. And as to the resources, Mr. Inoue, thank you for your question. As you may know, over many years, in Australia, we had an equity in coal mines and also operation right, and we have been engaged in operation of coal mines. The carbon dioxide reduction is now the mainstream in the world, and therefore, what to do with the coal that is produced? How can we translate or transform that into the low carbon solution? As one of such activities has to do with the expertise we gained in Australia, as well as the relationship that was developed, and the national staff with the mining technologies are there, and therefore their resources, expertise should be utilized for vanadium and lithium, the rare material, rare metal. And that's why we want to utilize such expertise and knowledge for application. In fact, this is the challenge to energy transition, and one of them has to do with from coal to lithium.
我々の知見を今後
That's where we want to
社会の実現に向けて
apply
生かしていこうと思っています。
our expertise to realize low carbon society, and in the field of battery, reuse, recycle,
いわゆるバリューチェーン、サプライチェーン
that has to do with the flow of value chain and supply chain. That's what we'd like to construct, and through those efforts, where we can play a role as Idemitsu. That's another question that we are currently looking into. Hope that this answered your question.
すみません、リチウム資源については将来
But
的に自
lithium
社
material
調達
that
の原
you
料を活用
will
されるという方針なのでしょう
procure the
か。
product material on yourself in-house and then make use of that
何分
material.
ですね、新しいやはり
Because
分野
this
で
is
す
a
ので、
brand new
知
area
見を持っ
so
た
that
方々
the
と
people with the
まあ
knowledge and experience
組みなが
are
らですね
necessary. We like
アライ
to
アンスを
partner
し
with
なが
them
ら
and
進め
through
ていくとい
forming
うのが
alliance, we like
現
to
実的な
promote
進め
that.
方
That
では
might
ない
be a
のか
more
なという
realistic
こと
way
で今
to
さ
advance.
まざまなケ
So
ースを想定
many
しながら
different cases
検討
that
してい
are
るところです。
considered now by us.
ご回答ありがとうござい
Thank you
ます
for your
ありがとうござい
answer.
ます。
はい、ありがとうございます。ではですね、
Next
こちらの列
question.
の前から2つ目の方、
The
お願いいたし
second,
ます。
the person in the second row, please.
中日新聞の杉藤と申します。
Sugito of 中日新聞.
本日はありがとうございます。
Thank you for this opportunity.
佐
My
藤社長の
question
で
is
すね、
to
プレゼンの
Mr.
中
Sato,
で、
President
初め
Sato.
て紀藤社長に会
For
わ
the
れた時
first time
に、
when you
エネ
met
ルギーの
Mr.
未来に
Kito,
ついて
that you talked about
共鳴
the
し合った
future
という
of
お
this
話がありました
energy,
けれ
and
ど
then you
も、
really
その
felt
点に
the
ついて、もう
sympathy
少
and
し具体
agreed.
的に、
Could
い
you
つ頃
please
会われた
specifically
んです
tell
か。
us when did you
どう
first
いった
meet?
シチュエーションだった
And
の
what
か
was
で
the
すね。そうい
situation?
った
How
その
did you
文脈の
encounter
お
with
話
each
の中
other?
で、
What was the
そういった
context
流れにな
that
った
you
のか
had
と
the
いう、
chance to
そう
get
いった
to
具体
meet
的
and
な
then
と
so
ころを少
forth?
し伺えれ
Could
ばと思
you
います。
please tell
よろ
us
しくお願い
more
します。両
details
社
about
長
that?
お願いできればと思い
This
ま
is a
す。
question to both presidents.
はい、
Thank you very much for your
紀藤さん
question.
もご質問ありがとうございました。ある意味ですね、この
In a way,
社長という立場になってですね、
when I
改め
became
て
president,
紀藤社
CEO,
長にご挨拶
and I
を差し上げた際に
went
ですね、
to greet him, Mr.
自動車産
Kito,
業、それか
and
ら
the
エネルギー
automobile
産
industry
業
and
の
energy
今後どう考
industry.
えるのかと
What
いう
do
よう
we
な、
think about the
ま
future
あ、あ
of
る意
both
味ク
industries?
ローズな中
In
で
other
ですね、
words,
互
in
い
a
の思いを
close
交換
setting,
する場
we
が
sort of exchange
あ
our
りました
views
ので、
and feelings.
先ほどエピソード
That
でご
was the
紹介した
opportunity
のは
as
私
I
社長就任後
introduced
の
that after I
話に
became
なります。
president,
た
I
だ改
had
め
a
て、
chance to meet him in that
二
way.
人で話をしている
And
中で
then
ですね、
when we are
やはり
discussing
これま
things,
で
just
自
two
動
of
車
us,
産業という
in
ス
the
コープ
past
の
we
中で
had
我々どうしても
worked
物を捉え
within
が
the
ちでし
scope
た
of the
が、
automotive industry.
カーボンニュートラルと
But
いう
now
も
we
のを
talk
実
about
現する
carbon
には、
neutrality
産
to
業を
achieve
超え
that.
た連
We
携
have
とい
to
う
go
のが
beyond the
やはり必要だろ
industrial,
うと。
the
それこそが
boundaries.
日
Collaboration
本
is
の国際
necessary
協力力を高め
because
ていくため
that
の
will
非
to
常に大
enhance
事
the
な
international
連携な
competitiveness
ん
of
じゃないか
Japan.
とい
And
う
that
こ
is
と
a
を
very
紀藤
crucial,
社長の
important
思いを伺っ
collaboration.
てです
And
ね、
I
感じ
felt
た
that
とい
feeling
うこと
from
でございま
Mr.
して、今
Kito
日先ほどの
and
プ
then
レゼンテーション
agreed
の
to
中で
him.
ですね、
That's
この
why I
紀藤社長
referred
の
to
熱
that.
い思いに
His
ですね、
passion
共
was
感して、
something
ま
that
あ、この
I
場が
was
実
impressed.
現したと
And
いう
that's
ことを紹介
has
させてい
become
ただ
the
きました。
starting point of this new collaboration between the
じゃあ
two
私か
companies.
らも
May I
ご質
also
問いただ
respond
きま
to that?
す。杉戸さんご質問ありがとうございます。
Thank you for your question.
私もですね、
I also
佐藤社長と最初にお会いした時に
felt that when I first met Mr.
ご挨
Sato,
拶のみならずですね、
we just
時間を多
greeted,
く
but
お忙し
we
い中
actually
取り入れ
spent
た
lots
社
of
長就任
time.
間もない
It's right
頃に
after he
時
became
間を
a
お取りいただい
president,
て
he
大変
took a long time
感謝
for me.
をしており
I
ます
really appreciated that
そし
he has
て
taken
さ
so
まざ
much
ま
time
な
for me.
角度から
And from
ト
many
ヨタ
different angles,
さんにおいては
we
マルチ
heard
パスウェ
about
イという
Toyota's
こと
multi
で
pathway
モビリティを
strategy. In
さ
other
ま
words,
ざまな形
mobility
で
will be
消費者お客様のニーズに応え
delivered
る
to
モビリテ
the
ィを
customers
展開していくとい
in
う
a different
もうコンセプ
mode
ト
and
の
modality.
基礎
So
ですね。
it is the basis of
これを
his
お聞きして
concept. And I heard his
私として
basic
は
concept.
エネルギー、
After listening
マ
to
テリア
that,
ル、素材を
our
扱う
energy and
企業
material
として
is our
本当にこのエネルギ
industry
ートランジシ
focus.
ョンに
So
いか
now
に
we
取
are
り組ん
faced
でい
with
く
the
べき
energy
かとい
transition
う
and
こと
how
に
we should cope with that.
思い悩み
So I was
私なり
wondering
の
what to
答え
do
を出
about
しな
that.
がら
I was
進ん
trying
でいる
to
つもり
reach
で
my
ございま
own
した。
solution. That was
この
how I was
考
dealing with
え
that
が
problem. But
佐藤社長の
when I
考
talked
え
to
と
Mr. Kato,
極めて
model. And then I felt that we really agreed on many points, sort of basically same thoughts, and I really felt so encouraged by hearing his word and his feelings and intention. Now, energy industry is going to change toward the carbon neutrality as the major breakthrough of technology is necessary. And then now mass consume the fossil fuel and other energy sources, but we cannot suddenly change them. But who is going to change and transform? Because energy and material, the users or the producers like us who had a lot of experience should be the central figure. Low energy transition toward the carbon neutrality is something where we are challenging. We have 16 projects last year.
中継の中で
in the midterm business plan that we announced those 16 projects. And then one by one, we are trying to implement them socially. Mass production is something we like to achieve. To what extent can we reduce the cost? In other words, the power to realize is crucial. Practically, the useful energy and material, what is it? So we had a frank exchange of views between two of us with Mr. Sato, and now we are talking about this SE because that was supposed to replace the fossil fuel oil, and how the crude oil's added value should be increased. 50 years ago, around the time of this first oil crisis, that Idemitsu Kosan has been doing R&D for that. As a result, we have this the organic agri-bio business as well as this new SE business, solid electrolytes business. So that's a background and story. And then Mr. Sato is advocating multi-pathway and mobility to support society. And two of our thoughts are quite similar. And I was very much impressed by his statement. Thank you for your
よく
question.
わかりました。ありがとうございま
It's
す。
very clear.
あ
Thank
りがとう
you.
ございました。では、そちらの窓の一番最前列の。
Then the person on the front row with glasses.
日刊自動車新聞社の福井と申します。
Fukui is my name. I'm from Nikkan Jidosha Shimbun, the daily car journal.
課題の一つであるんです。
One of the challenges of the solid the battery is about the cost. And I believe you're going to aggressively looking into the possibility of cost reduction as opposed to liquid battery. How competitive you could be. From around 27, 28, the first EV with that, that may be a little bit expensive with this technology. But you mentioned that you have to increase supply, otherwise cost may be rather difficult to be controlled. But eventually, what is the goal of the cost reduction that you are currently aiming for? And hope that we can hear from Mr. Sato of Toyota, which is going to assemble the final product. Thank you very much, Mr. Fukui.
コスト面については
About the cost?
やはり量との関係
In
が
fact,
当然相関がありますので
there is a relationship with the volume,
最
and
終的
therefore,
にその普及を目指すにあたっては
for
やはり
wider spread of the technology,
それ相応のボリュームが当
there
然
has
生
to be
産
certain
されている
amount of volume to be produced.
まず第一段階先ほどおっしゃられ
So
た
in the first step,
当面目指すのは
For the time being,
世の中に送り出していくということに重きを置いた
we will aim for
開発を進める
introducing
中
the
で
product
量が増えていった
into
時
the world,
の
and
生
then
産に関
once
す
a
る
certain volume is
キーポイン
achieved,
トを
and then the
具
key
現化しな
point
がら
in mass production
30年以降
would be
の
considered
量産
for
事業化という
realization
と
so
ころ
that we can
に
start commercialization and mass production
だから構
after
造いわゆる
2030.
原理原則的なことを考えますと
When we consider
一
the
定の
principles,
その構造
the,
体と
as compared to
要
liquid
素としてはそれほど大きく
battery,
違いませんの
they
で
actually, the
量
structure
産
itself is
あるい
not
は
that
そ
different.
の
So
普
for
及の
mass
段階において
production
は
or for
一定の現実
commercialization,
と
compared
同
to
等の目
liquid
線を持っ
battery,
て
I would
開
say
発を
that
進め
that
てい
will
くべき
be
だというふうには
viewed
考えております
in the
し
same way
最
as
終
a
的な商
liquid
品と
battery
し
in
てご
terms
提
of
供する上
development
では
eventually when it is
設計と
installed
同じ
into
ようなレベ
the
ルの
the final
車両
product.
価格を目指していくべきだろ
Then
う
the
と
price
いう
that
ふう
we
に考
should
えていま
aim
す。
for should be comparable to that of liquid
会社の
battery.
方からも若干補足申し上げて
Allow
よ
me
ろしいで
to
しょう
make
か。
some additional comment to
社
that.
長がおっしゃったことに対してちょっと補足もちょっと恐縮なんですけれど
Well,
も、
I somewhat
あの
hesitate to
実
make
際にやっぱりまだ
additional
駅の
comment to
電池
what
自
the
身も
president
まだ
stated,
まだ
but in
高い
fact,
っ
the
ていう
liquid
状
battery
況は
itself
皆
is
さん
very
よくご承知の通
expensive,
りかと思いま
as
す。
you may know.
ですので全固体電池が
So in the
で
case
き
of
る
all solid battery,
ように目指して今チャレンジしております
and
が、
that's what we are
全固体電池
facing
が
as a
世の
challenge.
中に出た暁の後も
Once
で
it
す
is
ね、やっ
introduced
ぱ
to
り
the world
液体の
and
電池
even
っていう
after
の
that,
はプロ
I
セ
believe
スそれからコ
the
ストっていうところをです
process
ね
and
特
cost
に大きく改善していかないと
for
続けてい
liquid
かないといけない
battery
と思って
also
います。
have to
その
be
コストという
improved.
観点ではその
From
進
cost
化
point
し
of
続
view,
ける液と
the
その
liquid
全固
battery
体
that
と
would
の
continue to
競争だ
evolve
と思っています。で
is going
一
to
つ
compete
そ
against
の
the
全固
solid
体電池
battery.
高いっていうふう
And
に
the solid
言われるんですけれ
battery
ども、
is
皆
always
さんの方でどうし
criticized
て
as
高い
too
のかって
expensive.
考えておられる方多い
Have you ever
たくさんおられる
considered
と
the
思うんです
reason
が、
why it
や
is
は
so
り基本
expensive?
は
I'm sure
い
many
ろ
of
い
you
ろ新しい材
did.
料を
In principle,
作らないといけない。
we have to
例え
create
ば今
new
回のイデミさん
materials.
のところも
For
そうなんです
instance,
けれども、
as in the case of
やはりそういった
Idemitsu,
新しい材料プラントっていうのは
the,
ス
you
ケ
need a
ールアップ
plant,
して、大きくやっていかないといけない。だけど
the plant
ニーズ
has
が
to
ないと
require
スケール
certain
アップをいき
size
なりしても
without a need.
結
If you
局
just
それ
upscale
が
the production,
無駄な投資になってしまうという
and
ところの
the
両
investment
含み
would
の
be
ような状
wasted.
況があります。 でそれを今回ブレイクスル
Therefore,
ーしていくためにです
for a
ね、
breakthrough to be
出光さん
achieved
と
together
ト
with
ヨタと
Idemitsu
その材料のところにも
and
一緒
Toyota,
に入り込んで
we
や
are
ろう
going
と
to
いう
work
意思を
together
示しており
and
ま
the
す。
material
で
as
こ
well,
の
material
実証
side as well.
27年、28年
And
というところで
27,
ですね、
28
まず
being
は
the,
全固
the
体電池を
commercialization,
も
that's
のにする
when
チャレンジをですね、ぜ
uh,
ひ
we
してい
want
きます
to
けれども、
introduce a
そ
solid
の
state
中で
battery
なんで
onto
高いのって言って
the
いうところを
EVs
シンプル
and
に考えると、
when we consider
高い
the
要素
question
っ
of why it is
て実際
expensive,
にはちょっとこれから
simply put,
もちろんチャレンジする内容ですけれども、
and in
シ
fact
ンプ
this
ルに考
relates
え
to
ると
what we need
液
to
系
work
電池と
on,
何が違うんだろうって考える
what's
と
the
そこ
difference
そ
with
こ
the
なんですよ
liquid
ね、基
battery?
本的に。
And in
です
fact,
の
that's a
で
key.
そういったところをですねしっかりやりな
So
がら
that's where we
全
need
固体
to
も液
further
もです
look
ね
into
よりコス
so
トダウンを
that
目指して
both the
切
solid
磋琢磨し
battery
て
and
で
liquid
適
battery
切な電
would
池を
aim
適
for
切なところに入れてい
reduce
く
the
と
cost
いう
and
ふう
then
にやって
introduce
世の中に広め
battery
ていきたいと考
wherever
え
that
て
is
ござ
the
います。
best
以
fit
上です。
for the final product to be introduced into the
あり
market.
がとうござ
Thank
い
you.
ます。続いてはですね、一旦オンラインでご参加の記
We'd
者の
like
方からも
to
ご質
give
問
the
をお受
floor
けしたいと
to
存
these
じます。
reporters participating online.
それではオンラインでご参加いただいている記者の皆様、ご質問がある方は画面上の手を挙げるボタンを押してお待ち
push
く
the
ださい。こ
button to raise your
ちら
hand
からお名前をお
on
呼
the
びし
screen
ますの
and
で、
we
マ
will
イク
call
と
out
カメ
your
ラをオ
name
ンにしてご
and
発
please
言をお
turn
願
on
いい
your
たします。
microphone and camera before you start speaking. Thank you.
では、オートモーティブニュースの岡村様、
岡村さんのオートモーティブニュース。
画面を切り替えますので、ご自身の映像が画面上に表示されましたらご発言をお願いい
The
たしま
image
す。
is on the screen. Please start to speak.
すいません、オートモーティブニュースの岡村です。
岡村、
聞こえますでしょうか。
Automotive News. I hope you can hear me. Yes, we
あ
can
りがとう
hear
ござい
you.
ます。よろしくお願
Thank
い
you
いたし
for
ま
this
す。
opportunity.
ですね、
First,
今回のこの協
because
業
this
の
time you announced this
投資額
collaboration.
というの
What is the
が
total
どれくらいなのか
investment
っていうこと詳細ま
amount
だ
that
出ていないので、
this
それについて教えていただき
require?
たいん
The
ですけれど、
details was never
先ほど佐
released.
藤社長のお
As
話の中
Mr.
で、
Sato, the president mentioned
最初はまず
that
とにかく世の
initially
中に出していて、
that you like to
2030 年
deliver
以
it
降っ
to
てい
the
うような話
society
ありま
and
したけれど、
2030you
その際の
might
量産
achieve this
可
more
能
of a
際
start
に、
to have
ま
a
あ
mass
ど
production.
のあ
But
た
in
り
the
で、そ
mass
して
production phase,
どのあたりでその量産化っていうのを
when
場所ですね、そのプラントのを考
and
えていらっしゃるの
which
かっていうのも合
plant
わせて
factory
お願
that
いい
you
たし
would
ま
start
す。
mass production? Thank you, Mr. Okamura, for your question. So, for SE, solid electrolyte mass production plant, the location we are thinking about eventually is not decided. But you can see the candidates, because this is our main the plant or chemical plant that is in Chiba, the prefecture of Chiba complex. And you can see the left-hand side, you can see that the oil refinery facility, and all those necessary functions are already there. And right-hand side, you see the chemical plant.
になってます。ですけど今これをですね順次アジアに移管をして
they are to be transferred to Asian countries. Therefore,
おそらく千葉が
probably
非
in
常に有力であろうというふう
Chiba
に
complex is a very promising site as a candidate site. Our research lab is also located in Chiba
そ
prefecture.
の連携ということを考
So
えたと
it
きはおそ
should
ら
be
く
collaborated.
私どもの千葉の事
So
業所
our
内で
Chiba
建設
complex
をする
site
という
is
ことが
likely candidate sites for the
合理的であろう
construction,
というふうに現時点で
rational
は考えて
the
います
site
最
to
終的
be
に決
built.
定はまだしてお
But
りませ
final
ん。
decision of the location is not yet
投資額
made.
はですね
As to
す
the
いませんまだわ
investment
かりま
level,
せん。
we don't know for the
現在
time
小
being.
型のプラントを持って
We
ま
have a
して、先ほど
small
申し上げましたよう
sized
に
plant.
27年度
In
にグリーンイノベーションの支
2027, the
援を受
Green
けまし
Innovation
て、
Fund
数百トン
subsidy
規
will
模
be
に上げ
given
ます。
several
年
hundred
産です
tons
ね。
of annual
量
volume
産
will
と
be
いうご質
achieved.
問でしたの
But your
で、
question is
量産
about
と
the
いうのはおそらく
commercialization
ワ
mass
ンライン
production.
数千トンクラス
In one line, that
で
several
あろうと思います。
thousands of
で
tons will be produced. That's the mass
数千
production
トンだと
scale.
多分
In that
車両に
case,
すると数
for the
万台というこ
vehicles,
と
it
にな
is
ると思いま
tens
す
of
けど、
thousands of vehicles
これについてはちょっと
to
慎重に
be
ですね、精査した
applied
上
with
で
this battery.
金
But
額の
we
方を
will
議論
very
このように
cautiously scrutinize that and then decide on the eventual investment
ありが
amount.
とうございました。
Thank you for your answer.
すみません。トヨタの海田ですけど、
I'm
ご質問ありが
Kaita
とう
of
ございま
Toyota.
す。
Thanks for this question.
材料だけじゃなくて、せっ
In
かくなん
addition to
で
material,
全固体電池の
I'd like
製
to
造
talk
設備に
about
ついて
this
も
production
補
facility
足
for
と
this
いうか
all
さ
solid
せてい
state
ただければ
battery.
と
So
思って
it's a supplementary comment to
電
your
固体電
question.
池の
All
製
solid
造設備
state
につきまして
batteries
は、
production
弊社の本社
facility
地区でというふうに
in
考
our
えて
head
ございま
office
す。や
district
っぱ
to
り
the
このカ
candidate
ーボンニュー
site
トラルに向け
because
ての
to
ですね、
achieve the
様々
carbon
なリノベー
neutrality,
ションがあるという
many
こと
different
と、
types of
やっぱり開
innovation
発時に
needs.
近いところ
And
で
then we have
最
to
初のライ
really
ンを
have
立ち
the
上げていく。
first
そこの
line
やっぱ
to
ク
be
ロスターという
established
ところを
near
ですね、
this
考えなが
R&D
ら、
place so
そ
that
こは
the
そこで考えています。で、
vicinity
規模なんで
site
すけ
should
れ
be
ども、
chosen and the
実際に
scale
その
of
や
the
っぱ
plant.
電気の投資ライン
Actually,
って考え
the
てみるとです
battery
ね、
production
後からのその
line
電
to
池
be
が完成
invested
した後のエイジングだと
after
か、
this
それだ
production
と
of the
か、
battery that the aging and
まあ
other
異
processes
物がないか
necessary
というとこ
and
ろ
we
を
have to
確認する
identify
プロセ
this
ス、
foreign
ここのところのですね、
these
倉庫
item
のよう
and
な
then
重放
so
電
forth
装
from
置
there
というか、
so
そういっ
that
たところが
so
です
you
ね、
need
非
a
常にマ
warehouse
スが
like
ご
a
ざいます。
facility
で、いきな
that
りそこを広げる
needs
と
to
いうわ
keep
け
it
では
so
な
you
く
can
て、
suddenly
各加
expand
工
the
店、加工
facility
するとこ
for
ろを組み
each
立てたり、
production
まあ
site
こ
as
う
well
いっ
as
た材料を売っ
assembly
たりです
line
ね、そういっ
as
た
well
と
the
ころの能
material
力は
the
しっかり
production preparation
本物
all
の
that
そ
capacity
の
should
まあ
be
ス
there
ピードがですね、
so the
検証できる、そうい
full-fledged
ったものを
speed
です
should be
ね、
verified
最初のラインにもですね、しっ
so
かり
in the
取り入れ
initial
なが
line
ら、
all
そういっ
that
たサイズ
the
感で、
capability should be
ま
already
あ
stored so
ト
that
ヨ
is
タ
a
の本社
size
地区にですね、
of
そういっ
that
たも
new
のを作
facility
っていき
which
たい
should
とい
be
うふう
built
に今考え
in the
てござい
Toyota
ます。
head
すいま
office
せん、補足です。
site area. Thank you. That's
あり
my
がとうござい
additional
ました。
comment.
ありがとうございました。
Thank you.
続きまして、岡崎五郎様、お願いいたし
Goro
ます。
Okazaki, you will be the next.
Good
afternoon. Can you hear me?
はい、聞こえております。
Yes, we can hear you. Thank you for the opportunity. Mr. Sato, I have a question about all solid state battery, which is said to be a game changer. But doesn't mean that all the cars equipped with the all solid battery would be loved by their drivers. So the question is, what kind of car you are going to produce? The battery EV that will be produced by car maker, that's what you're always advocating for. So to you, with the new weapon like a solid state battery, what kind of the attractive car that you can produce with that technology?
はい、岡崎様ご質問ありがとうござい
Thank you
ま
very
す。
much for your question, Mr. Okazaki.
これまでもやっぱり車の作るバッテリ
In
ー
fact,
という
I
ことに
was
こだわってい
always
ろいろな取り組みをやっておりますが、
emphasizing various initiatives for the EVs with the batteries produced by car
要
makers.
素が入ると
With this new
車
element,
にお
the
ける
factor that
い
is
く
an
つか
all
の
solid
大きな
battery,
パラ
that
ダイムチェン
means
ジがあると
there could
いうふうに
be
思っています
major paradigm
一つはやは
shifts.
りエネルギー密度が
First of all,
液体よ
energy
りも高く設
density
定
would be
できます
higher
の
compared to
で
liquid
バ
battery,
ッテリー EV としての基
so
本
that
的
the
な素性を
battery
高める
EV
ことができると。
performance
これは
could
イコ
be
ール
enhanced. That
その他のと
means
ころで
for
例えば
other
空力
aspects
に徹
like
底的に依存して
aerodynamic dependent
車の開発をやっていく
development
というこ
for a
と
car,
よりも少し自由度が出て魅力的
compared to
な
that,
デザイン
you
あ
would
るい
have
は
more
キャビンのパッケージ
freedom
に有
for
利な空間を
attractive
設計する
design
ことがよ
and
りやり
more
やすい環境に
attractive
なっていく
cabin
と思います
design that will be
多様
enabled with
な
that,
選択肢
rather
お客
than
様の期
just
待に応えていく
relying
た
on the
めの
aerodynamic
魅力
aspect
ある
and
車
then
の
trying
一番
to
一番地はやはり
cater
かっ
to
こよ
and
くて
respond to the needs.
走のいい性能のいい
It
車
has
だ
to
ろう
be
という
a
ふうに
good
思います
performance,
と
high performance
そういっ
car.
た自由度が高まっていくというと
So
こ
with
ろ
a
は
higher
一つ
degree of freedom,
車のこだわりと
I
し
would
ては
say that
利点
for
に
a
なる
car
かなというふう
maker
に
like
思いま
us,
す。
that would give
それ
us
か
an
ら
advantage.
エネルギー密度が上がるイコールやっぱり
And
体積効率
higher
が上がり
energy
ますので
density
パッ
means
ケージの自由
that
度
there
が
will be
よ
more
り上がって
efficient
いくという
volume
こ
use,
と
and
にな
therefore
り
there
ま
will
す。
be more
低
degree of
重
freedom
心
for a
でか
package,
つ
lower
いわゆる
center
キャ
of
ビンスペースに
gravity,
多くのスペースを
with
取る
more
ことがで
space
き
for
る
cabin.
レイアウトフリーな
The
バッテリー
layer-free
ということを
battery
やっていけるようにより
is
なっ
what
て
is
いきま
going
すの
to
で
be
こ
available,
れ
and
が使え
therefore
る車群というのは大変多く増え
the
ていく
group
と
of
思います。
cars that
それから
can utilize
3
that
つ目これ
technology
最後になるんです
would
けれども
increase. And thirdly,
いわゆる重放電特性いわゆ
the
る
given the
電気エネルギーのやり
charging
取りのスピード
discharging
が
electronics that's about the higher speed of or faster speed of the exchange of electric iron. That means the commercial vehicles that require recharging frequently, this could be another application, and therefore
今までのバッテリー EV が
compared
使え
to
る
conventional battery EVs.
オートモービルの領域がこれ広がるということ
The,
に
in
なってい
fact,
くというふうに思います
the
の
scope
で、
of
そう
the
いう
battery
乗
EVs
用の
could
み
be
ならず
expanded
商用
with
の領
this.
域まで
Therefore,
幅広く
not only for
モビリティ
regular
の
battery,
変化を生み
the
出す可能
EVs,
性
but
が出て
also
くると
commercial
いう
vehicles
こ
as
とだろ
well.
うと思います。まあ、い
This
ずれにしまし
technology
て
could
も、
be applied
電池そのも
at
の
any
で
rate
車の価値が
with battery
一義的に
itself.
決まるわけではないと
Of
いう
course,
ふう
it
に
does not
先
decide
ほ
the
ど
value
の
of the
ご質問に
car.
もお答えした通りですね。やは
As
り
I
最終
mentioned
的には
earlier in
こ
responding to
の
one of
強
the
みを生か
questions,
していかに車
the
としての
key is
魅
how
力
to
を
take
高めてい
advantage
く
of
努力を
this
続けるかと
technology so that
い
we
うこ
can
とになろ
further
うかと
improve
思
the
いますの
competitive
で、
edge
こういっ
and
た
attractiveness of the car.
ある意味大きな変化点になる技術をし
In
っ
a
かり
way,
とらまえて、
this is a technology that
そ
would
の
bring
良
us
さを生か
the
す
major
車
sea
の
change
開
or
発を
turning
今後
point,
とも
and
やっていきた
therefore
い
we
という
should
ふうに思って
consider
い
how
ます。
we can
以
make
上
the
です。
best use of such
はい、あり
a
がとうございました。
transformative, disruptive technology. Thank you.
はい、それでは続きまして
The next speaker,
日
please.
本放送畑
From
中様お願いいたし
Nippon
ま
Hoso,
す。
Hatanaka-san, please.
画面を切り替えますので、
And we
ご
will
自身
switch
の
the
映像
screen.
が画面上に表
When
示さ
you
れました
appear
ら、
on
ご
the
発言お願い
screen,
いた
please
しま
start
す。
to ask a question. Thank you.
はい、日本放送畑
Thank
中
you.
と
I'm
申しますが、聞
Hatanaka
こ
of
えますでしょう
Nihon Hoso.
か。
Can you hear me?
はい、聞こえておりま
Yes,
す。
we can.
はい、よろしくお願いし
Thank
ま
you
す。
for this
今
opportunity.
回の
In this,
協業でですね、
the collaboration you are
プ
just
ライムプラ
announced,
ネット、
the
パナソニッ
Prime
クと車
Planet,
載
that
電
is
池の協業には
your
影
the
響を与えるんでしょ
collaboration
う
with
か。これは
Panasonic, would that be
点が
impacted?
線になっていくよう
Because
な
that all
話な
the
のか、
dots will
全
be
く次元
connected
の
by
違う
lines,
話である
or
の
did
か。
your
合
collaboration
わ
with
せて今
Panasonic
回
a
の協
totally
業
different
を合弁
dimension?
会社を設けてい
Because
くよう
that
な展開
will
に
you
なるのか、
establish a
これ
joint
をお
venture
聞きしたい
company
です。
by
お願い
two
しま
of
す。
you, or what will be the future outlook of your joint
畑
collaboration?
中様、
Thank
ご
you,
質問
Mr.
ありがとうござい
Hatanaka,
ます。
for your question.
ご質問には会社の方から
So,
お答え申し
Kaita
上
would
げま
like
す。
to respond to this
まあ
question.
点が線という
Because
か、
all
なんか
those
イメージからする
points
と
and
ですね、
dots will be
線
now
を
connected to
面
be
に
connected
広げてい
lines.
くという
We
ふう
like
な
to
イメ
expand
ージ
it
で
to
考え
this
てございます
plane,
が、
two
こういった
dimensional.
新
In other
しい
words,
技
that
術
this is a
につ
new,
きましては
brand
で
new
すね、
technology. So
PPS とも
PPS
ですね、今電池
and
の液系の電池で
we
改良、
are
それから
improving this
まあ
the
そこも
liquid the
イノベ
battery.
ーションというか
And
新しいタイプの電
innovation,
池
a
を
new
させてい
type
た
of
だいております
batteries
けれど
is
も、
being developed
そ
now
ちらの方に
in
もで
that
すね、
area.
やっぱり全固体電池と
So
いうのは
that
技術とし
the
て
also
い
the
ずれ
battery as a
供給をしてい
technology
くと
should
いう
be
ふうな形
the
で、
supplied
さ
in
ら
the
に発
future
展させ
to
て
the
広く
other
と
parties
い
so
うふ
that
うに
it should
考え
be
てございます。
widely
まあ当然なが
used
らそのためには
eventually.
先ほど申し
So
上げ
of
たよう
course,
に、
naturally
ま
to
ず
achieve
27
that
年から
first
28
27
年
to
のその
28,
チャレンジを
that
確実なもの
our
にして、
first
でそ
challenge
れか
and
ら
goal should
量
be
産化
met
技
first.
術とし
And
て
then
しっ
as a
かり
mass production
育
technology, it
て
should be
て、で
ensured
そういった
and
形
nurtured.
で
And
PPS
based
さん
upon
と
that,
も
PPS
う
and
一緒
us
にやってい
would
きたい
like
という
to
ふうに
work
考えてござい
together
ます。
further, so collaboration scope will expand in that way.
合弁会社の件はいか
So
がでしょう
what
か。
about the joint venture possibility?
新たに合弁会社
A
を
new
作るとかそうい
joint
う
venture to be
話
established? Is
の
that
ご質
the
問だ
gist
と
of
思え
your
ばいいですか。
question?
はい、そうです。
Yes,
そうです。
that's my question.
そういった点は
About that
ないの
possibility
で
of
はない
joint
かと思って
venture,
ます。
I do not
そも
think
そ
that
もないっていう
is
か私がお答えす
in
る
the
のもなん
option.
ですけれども、
I should not
電
be
池
the
っ
one
てい
to
うの
answer,
は
but battery.
電池の種類が違ったら
There are
会社
different
を
types of
変
battery.
えるというようなものではな
Not
く
to
て、
switch
や
the
っぱり
company,
そ
but
のお
rather
客様のニーズ、
that
それ
we
から
have to
車の
respond
ニ
to
ーズ
the
に合
need
わ
of
せ
the
て
customers and the
必要なも
vehicles
のを
and what is
供給していかな
necessary
いとい
should
け
be
ないという
supplied.
ふうに考えてございますので、
That's the
今はそういうふう
idea
に考
toward
えてい
the
くのでは
battery
ないかという
supply.
ふう
And
に
so
考え
that's
て
the
おります。
current scenario.
はい、ありがとうございました。
すみません、
Thank you.
佐藤から少し補足をさせていただきたいと思い
Sato
ます。
speaking. I'd like to make some additional comments
最後2つ目の合弁会社を設
about the
置する
second
のかどう
point.
か
That's
ということに
about
ついてです
the
が、私のプレゼンテーション
question
の
on
中で
joint
もお話
venture.
し申
In my
し上げたよう
organization, I think I mentioned that first of all, that we will start considering the pilot plant by selecting members from both companies, and then that will be the team to consider jointly, starting from the dozens of members and eventually toward the mass production, with a more concrete plan to be developed. This organization, the team, has to be flexibly structured, and then eventually on the extension of that, if we see the need for establishing a new entity, that will be when we consider the possibility of establishing such an organization. But for now, we would like to unite, have a one united team to take advantage of technological advantages of both companies, and then decide how to best start this initiative. So eventually, once we are in such a phase to consider such possibility, then we might consider discussing such the establishment of an organization with my counterpart. Thank you. I also share the same idea. Hito speaking. Thank you very much. Thank you very much for your participation remotely. Now I'd like to come back to those that are in the hall. The second from the front row, the fifth from the door, the one that is wearing mask.
失礼しました。輸送経済新聞社の遠藤と申します。
遠藤 from 輸送経済新聞。
佐藤社長、冒頭
Mr. Sato,
スポーツカーから
at the beginning you mentioned about the possible coverage of sports car all the way to commercial vehicles with this technology. Trucks and buses, that's my question. The high output and the long cruising range and durability, the requirements would be even higher compared to passenger vehicles. So you start from passenger vehicle and eventually move on to the commercial vehicle. Or what are you planning for commercial vehicles for development? And also, what could be the level of the performance of commercial vehicles that you can achieve with trucks and buses? Thank you, Mr. Endo, for your question. About commercial vehicles, there will be more opportunities. In fact, that's because of the volume density or energy density. They will be enhanced greatly, and therefore, compared to a liquid battery, especially in the case of commercial vehicles, which requires to carry heavy volume of load of cargo, because of the high percentage of the battery that would be there to carry such a high volume, and also recharging time, that will be a key for commercial vehicle application. So in that sense, as a potential, I'd say that for commercial vehicle application, this is a battery that has a distinct advantage. On the other hand, eventually, this is toward carbon neutrality, which could be translated as energy security. In other words, rather than relying on electricity, according to the applications, we might consider using hydrogen versus electricity, depending on the application. CJPT and other activities are introduced, and elsewhere, the fuel cell possibility for commercial vehicle application, that's where we also see the progress of technology, and therefore, the way it is used or how the infrastructure is developed or energy security situation in different countries, depending on that, if electricity is a better choice, then we might choose it. If it is hydrogen instead, and then in that particular regional market, we might consider using hydrogen as an energy source. In other words, we want to cater to the wide variety of needs by preparing for the wide range of options, alternatives. That's what we are planning to do, and therefore, from that point of view, there will be the potential possibility for commercial vehicle application. Thank you.
The person wearing the white blouse on the second row from the right. Take from Nikkei Asia. Thanks for this opportunity. Two companies will start up the pilot facilities, and you already announced that pilot facility. What is the specific schedule? 2027 and 28 are the time schedule in the upcoming 4 years. Could you please give us a more specific timetable for implementation? And in that plan, that is the SE. Now you have a sulfide-based material, but in addition, do you have any other raw material, other options of material? So in your R&D, in some cases, you might switch and shift to other materials than the sulfide-based material. Could you please tell us more about this? Thank you, Mr. Take, for your question about our time schedule. Nakamoto would like to answer. As I said, Toyota 27, 28 time schedule, and we have to really meet that timeline required by Toyota. 27, we'd like to start operation. That's the basis of the schedule target, and then detailed time schedules are currently being drafted according to that deadline. So the several tons of the production volume per year, and then eventually mass production facility of several thousand tons, or tens of thousands of vehicles, so that the vehicle plan in the Toyota, the volume plan in the Toyota will be the basis, and we'd like to respond to their requirements, and at the optimal timing, we'd like to make the decision as to the exact time. Mr. Kaita maybe should answer the second question. Thank you. I would like to respond to the second part of the question about this SE. Basically, the Idemitsu and we are collaborating. That's a major type of material. But our company also, for example, has working with the Tokyo Institute of Technology to develop material LGPS and so forth. That is another type, and also the crystal type material, and then the oxide type material. There are different candidates materials. The performance is very important, and you have to really judge based upon the performance. The target, the vehicle's performance should be determined, and eventual product requirements, and then you will backtrack, and then what is optimal material, which should be developed most expeditiously and to be distributed widely. Taking those requirements into account, the current material working with Idemitsu is the most priority candidate material, and that's how we came to this conclusion from this material. The possibility to shift to other material, of course, the possibility is not something that we can totally deny, because the technology is evolving very rapidly. But for the time being, we give most priority to this material developed together with Idemitsu, and 28 and 28 are our the target dates to release that. So, what about compared to other candidate materials? You said that this sulfur-based material has a higher the flexibility or the softness requirements, and then of course it's suitable for the large volume. So the property is more excellent than the other candidate materials. Yes, when you consider all the total aspects at the moment, that is our decision to choose this material. Thank you.
では、鶴側の席の、メガネの方。
Then the person wearing glasses seated on the aisle side.
すみません、東洋経済の森と申しますけれども。
Mori of Toyo Keizai speaking.
先ほどからIdemitsuの
From some time ago, we have been hearing about the advantages of Idemitsu. But I'd like to once again ask that question. In terms of the material patent, Toyota has a patent, and then the Idemitsu has an IP for production. What does it mean by the production IP? Is that the press or the material itself? Or if you can tell us more about the production technology, and also in phase 1, in terms of the quality delivery and so on, this would be further developed. But if you can elaborate more on that to tell us what it means. Thank you very much, Mr. Mori. I am Nakamoto speaking. In terms of production of material, I'd like to make some comment on. If I can have a slide. No, not this one. Remember the chart with the material flow? Oh, I can speak on this as well. Oh, if you can go back. But anyway, the development of material and production. 2 points of views that I'm going to touch on. So this is about the development. As you see, to begin with, the solid electrolyte for EV has been the research target for more than 20 years. And then, together with Toyota, we started working for about 10 years, I think, and design the material, the expertise for that, we have accumulated expertise. And in terms of IP, the basic patent that's held by Toyota.
で、ただ私どももこの
That's so
材料に
clear.
ついての選択
But
的
for
な
the
特許っていう
material,
の
we
は
have some selective
たくさん出願
patents.
しておりますし、
We made
別のスライドで見
the
ていただいた
various
通り、
applications.
トヨタさんと私ども
And
の
as you have seen
特許
in
の
different
数を
slides,
合算
if
するとです
you
ね、
combine the number of
もの
patents
す
held
ご
by
い
Toyota and
6割とか
Idemitsu,
7割ぐらい
that
の
will
シェアを持ってい
be
るというふうに思います。
about 70%
で、今度は
of
これ
all the
設計したら
patents
それで終わ
related
りじゃ
to
な
this
くて、
technology.
実
But
際
of
に
course,
合成し
designing
て
is not
こ
the
の
end of the
ものを
story.
作ら
We
ないと
have
いけ
to
ない。
synthesize
で、そ
and
れ
then
を電池に
produce
して電池強化をするこのサイ
and
クルを
then
ぐるっと
put it
回す。
into the
で、今こ
battery
れも MI 使
to
い
turn
使
the
わないなんて
cycle.
ことはこれありえないわ
It
け
is
でございま
unthinkable
して、
that we will
こ
not
れを
use MI
いわ
and
ゆる
therefore
アジャイルに回していくっていうの
this
が
has to
私ど
be
もの開発の一つの
promoted
強み
in
でございま
agile
す。で、
fashion.
次に作るの方
And
に行って
that's
いただ
the
けますか。
strength that we have. And now, could I have another slide that shows production?
ここでですね、固体電解、
Here,
硫化リチウムもそうなんですけど、こ
the
れは
for
状
lithium
態で言う
sulfide as
と
well.
粉です。
This is in the
微粉
powdery form.
です。
It's
で、
an
ところ
ultrafine
が
particle.
作りやすい微粉をやればいいっていうわけじゃなくて
It
です
doesn't
ね、
mean that
これを
they
トヨタ
just
さ
to
んに渡
produce
して、トヨタ
ultrafine
さんが
particle
電
that
池に
is
した
easy
と
to
きに
produce.
最も作
That's
りや
not
す
the
くて
right
最
answer.
も性能
Rather,
が出るた
it
めに
has to
は
be
どうするか。
the easiest
例えば
for
粒
Toyota
の
to
大きさ、
use
そ
for
の粒
best
の形、
performance,
これをどう
the
いう
shape
ふう
and
にするかっ
size
ていう
of
と
the
ころがものすご
particle.
い肝になる
That
と思
will
い
be
ま
the
す。
key.
その意味でトヨタ様と私ども
Therefore,
で
together
これを
with
一緒にやってい
Toyota,
くということはですね、非常に大きな技術上
as
の
we're going to
価値が
develop
あるというふうに
jointly,
思
that
いま
will
す。で、
produce
もちろん私ど
significant
もは
value
長年
to
の事業
this
を通じまし
technology.
て、
Throughout
微粒子
many
の
years
取り
of
扱いの技術
technologies
で
or
あるとか、高
experiences,
純度化の技術は
we
保
have
有しています。
technologies
これと
for
トヨタ様
handling
の電池の技
ultrafine
術、これを
particles
い
as
か
well
に
as
合体さ
production
せるか。
technologies. And
これが
it has to be
ま
combined
さに日
together
本の
with the
技
battery
術の力に
technology
なる
that
であろう
Toyota
と
has.
いうふうに私どもは
That
考え
would
ており
point
ます。
to the high level of the strength
以
of
上ご回答
Japanese
申し上げます。
technologies. Hope that this answered your question. Does it answer your
すみませ
question?
ん、少し付け加えさせていただけれ
If
ば
I
と思い
may
ます。
add,
一つ前の資料を表
in the
示いただける
previous
と
slide, the one that we saw earlier,
中本さんおっしゃられたことと同
as
じ
Mr.
ことを
Nakamoto
申し上
mentioned,
げ
in
てしまうかも
fact,
しれ
what
ませ
I'm
ん
going
が、
to say may be essentially the
我々自動
same.
車メーカーから見た
For
とき
car
にです
maker
ね、
like
出
us,
水さんの固体電解質の強み
Idemitsu
とい
has
う
solid
のは、
electrolyte,
この
which
資料にあ
has
る
a
耐
strength.
水性、イオン
As you
伝
see,
導性、柔らかさ、この3
the
つを
moisture stability,
実現し
ionic
うる作り
conductivity,
方
and
が
mechanical
できているとい
properties,
うこと
and they
に
have
あ
a
ると思い
technology
ま
to
す。
realize those
材料の
properties.
組成が何で、どれをど
And
れぐら
the
い配
material
合
is
すれ
made of
ば
what, and what is the
固体電
combination
解質
of
として
mixing which
有効な
ingredient
材料なの
to
か、
make
こういう
the
材料成分的
effective,
な
the
話
solid
はもちろ
electrolyte.
んそこにも
Of
技術
course,
があるんですが、
there is a
じゃあそ
technology
れ
to
を
it related to
均質
ingredients,
性、均
but
一
then
均一に
homogeneity to
住所を並べ
homogeneously
て密着性が
the
高くて
the layout,
かつ
the
柔軟性があって
the molecules,
形状
and
変
it
化
has to
に
be
追従がしやすい
adhesive, and at the
柔らかさ
same
に
time
作
it
り
has to
込
be
む。
flexible
で
enough.
水分に対してやはり
And also,
弱いもんですから、
because
その
of the
水に対して
the weakness
強い
against
作り
moisture,
方
it has to be
をどうやって
the
実現
resistant
すれ
to
ばできるの
moisture.
か。
How
こういう
can
と
we
ころはですね、
produce moisture
単に材
stability
料の組成だけで決まらない固
product
体電解質の
that's not
いわゆる
determined
競争
only
力の
by the
源
ingredients
泉
or
になっておりま
materials,
して、まさに
and
出水さ
yet
ん
that
が
would
実現さ
determine
れ
the
ているのは、
competitive
ここ
edge
に
of the
挙げられて
battery.
いる3つの要素
And
を
those three factors
そのレシピというのは
are the
おそらく
ones
それが
that Idemitsu
ノウハ
has
ウ
a
であり
recipe to realize,
具
or
体
you
的に
can
開
call
示する
it
ということではないんですけ
expertise.
ども、ここに強みがある。これを
So
実
that's
現
where
で
they
きる
have a
作り方が
strength,
できると。
and they can
で、さら
realize
にその精
those
度を上げていく
properties
ため
with
の
their technology and
パラメー
expertise.
タースタディ
And
といいます
also,
か、
the parameter
検討
study
研
to
究を
further
進
improve
め
the
ていく。
performance
これ
is
はこれから
what
行われていくことだと
we
い
are
うふう
going
に
to look
我々
into
は理
together.
解しております。
ありがとうございます。
Thank you.
これはじゃあつまりこの 10年
In
の
other words,
月日っておっしゃってもこれは
You
もう
mentioned
10
about
年
10
来
years.
そういうことを
So
こう
this has been the
やり取
project
りしながら
for 10
今日に
years,
至る
and you
そう
have
いう
been
理解でよろしいですか。
engaged in interaction for the past 10 years. Is that a correct way to state that? Yes, Kaita speaking. Yes, we have been interacting with each other for 10 years. And as Nakamoto-san responded, and now you might have understood already, it's not just about the high performance. They're to facilitate the battery production and then also produce better performance. So the way battery is produced and the performance of the car that is equipped with that battery, those are the areas where Idemitsu has in-depth understanding and knowledge about. So IPs, as well as other areas where Idemitsu Toyota 10-year relationship has accumulated too, with close mutual understanding. That's culminated into such a technology, and hope that you would understand how this was achieved through the interaction between the two. Thank you.
So, a person in the fourth row wearing the suits, please. Yoshida of Yomiuri Shimbun. I have a question to the two gentlemen from Idemitsu Kosan. In your first speech, you said that the ion element study started in the mid-1990s, very early stage. And in the handout material shows that in 2001, that this the all-solid the battery elements and components study was launched, but in 1990 already, in 1995, so the sulfur the study started. What was the social environment and business environment? What was the backdrop? Why you decided to focus on this byproduct of your oil refinery, that is a sulfur component? At that time, were you thinking about application of that material toward this all-solid-state battery for the vehicles? But what was the initial purpose of researching on the sulfur material? What kind of factors actually have induced you to shift your focus to this more development of all-solid-state battery for vehicles and so on? Thank you, Mr. Yoshida, for your question. Initially, 1994 or so, that yes, in 1990s already we started this research activity on this. As I mentioned earlier, the oil crisis, the first one, the second one, struck us. Initially, we knew and we said that the oil is the finite resources which will eventually be depleted because some of this the reserve and so on, and then the exploitable resources are limited. Only in 40 years it will run out. But what will be the replacement alternative energy or material to replace oil? That was something we started research, and our focus was how can we add the value added to oil and effectively and use oil. So in broad range of area, we did a research for that purpose. As a result of the R&D, we have some residual benefit and outcome of that research as time went by. Of course, we decided a different focus, that is the environment consideration. The energy which would not emit the CO2 or the material which would not emit the CO2, that will be required. In other words, the purpose has changed in our R&D, but the fossil fuel is of course a cheap and high energy density product which would not get wear or does not get damaged and so on. It's cheap and so forth. So how can we change the oil to have a more the added value product? And as a result of all these diversified efforts, we come to this finding on this sulfur compound, because through the refinery, the high purified that is the byproduct comes, but it's a byproduct, so it's a cheap, high purity sulfur. So maybe we can make use of that. And that's how the starting point to decide to develop an all-state solid-state battery. Nakamoto could elaborate on that. Thank you for your question. So originally, initially, of course, we are the energy company. Oil chemical is another aspect of business, and so that oil chemical business for that purpose, yes, we don't have that material here, but anyway, that before creating all solid-state material, there is a sulfur-based lithium, and so lithium sulfide, and then maybe that could be utilized. So regardless of EV, because the electric vehicle was not in the idea at that time, but in 2001 already, in the future, we could think about EV. That might be a future, remote future scenario. And so we judged that as a potential. So utilization, application has been now focused on since 2001. So the electric vehicle became another new priority area for us. That's why we continue this research. Thank you very much.
ではですね、3列目のメガネのはい。
The person wearing glasses, the third row from the front.
フリーランスの永井と申します。
長井 I'm a freelance journalist.
硫化物を積んだ車が市街地を走ると、
The cars equipped with the sulfide isn't it dangerous in case of accident, especially when it's raining. The toxic gas may be generated.
それを対応する技術とはもうすでに確立されてるんでしょうか。
Is there technology to cope with that? If you can tell us technology that's already developed, and also the mass production of sulfide, that would be extremely challenging. In production of sulfide, how can you ensure safety to prevent accidents? What are the points that you focus on in preventing accidents? So battery aspect as well as the installing it onto the car and the final assembly. What are the keys for consideration? Thank you very much, Nagai-san, for your question. As you rightly pointed out, sulfide, if it is not properly handled, or the system is wrong, or if the ingredient is wrong, then what you have just mentioned could happen. So first of all, material, the battery and assembly, and the battery system, the car, entire car system. So there will be 4 layers that we should ensure safety. And we now have a confidence that we can achieve that. Simply put, on the part of Idemitsu for the material to the moisture, such danger that could emerge, they have a moisture resistance material. So that's one of the reasons why we chose them as the candidate material, I mean. And EVs, of course.
よろしくないっていうか、いろいろその市場ではですね、
In the market,
燃えてしまっただとかいろいろ
some say that
話がですね出てはおりますけれども、
there are various scandals or accidents, including the burning out the EVs.
トヨタもそうですけれども、
like
まず
others,
その電池のシステ
on the
ム、
part
そ
of
れから
Toyota,
車のシ
first
ス
of
テ
all,
ム
the
を
battery
含め
system
て
and
し
the
っかり
car
結果的
system.
にお客様に安全なものにす
We
る
are
と
looking
いうふう
into
に
them
してございます。
so that
ちょっと
the
技
entire
術の
system
詳
would
細
be
になります
safe
の
for
で、
the drivers,
詳しくは
users.
申し上げら
I
れませ
cannot
んけれども、
elaborate
そう
on
いった
details because it
状況
has
に
to
対し
do
て
with
の
the
メ
sensitive
ドは
information
つけ
about
て
the
対
technology.
応してございます。
But I can only say that we now have a confidence that we can respond to such a situation.
ご質問ありがとうござい
Thank
ま
you for
す。
the question.
材料サイド
About the
でもですね、
material
今トヨ
aspect,
タさんの方から電池パックア
we
レン
have
ジシス
just
テム
heard about
トータ
the
ルでの対
battery
応を取られ
pack
ている
and
と
the
いう
entire
話だったと思うん
system,
ですけ
various
れども、
measures are
ちょっ
taken.
とこれ私のも詳細は差し控えさせていただ
And
き
on my
ますが、
part as well, I cannot
材
elaborate
料そ
on
の
details, but the material itself
でいわゆる硫化水素の発生を
is as
抑える
such
と
to
いうものを
prevent
設計の中に組み入れ
the
て、
production of
ゼロにはできません
the
けれども、
sulfide hydrogen
できるだけ
that's incorporated as a part of the design. Of course, we cannot eliminate the possibility to zero, but we're trying to minimize that as much as possible in the design process, starting from the design process. Thank you.
はい、ではですね、そろそろ多くのご質問いただいておりますので、残りお二方
already
ごさせて
entertained
いた
so
だ
many
ければ
questions,
と
but
思い
we'd
ます。
like to
こちら
entertain two
の
more
前
questions.
の黒いシャツの方、
So
お願いいた
the
します。
person wearing black shirt, please, in the front area.
日経オートモーティブの久米と言います。よろしくお
Kume
願
of
いし
Nikkei
ます。
Automotive, thanks.
2030
So
年以降の
2020 and afterwards,
数万台レベルと
you
い
would
うと
like
こ
to
ろ
achieve
で、まあ
the
本格
high
量産に向
volume,
け
that
て
is a
お伺いしたいと
full-fledged
思います。
the mass production
今
of
回
20 or
2社で
30,000 units, but
本
now
格
two
量産に向け
companies
た壁を越えていくためのチャレン
overcoming
ジ、
the
まあ、2社
barriers
でやること
of
と、
this
あ
the
と
mass
は
production.
トヨタさん
Two
と
companies
して
are
はその2
collaborating.
社以
But
外、
of course,
まあ、それ以
aside
外
from
のイ
those
ベン
two
トで
companies,
は、
maybe
まあ、
TMC
本
can
格量
think of
産について
other
のまあ不止まりですとか
partners.
タクトタイムみたいなところ
The
も
takt
まあいろい
time
ろあ
as
る
well,
か
the
と思い
yield
ま
have
すの
to be
で、
also
まあ、現
improved
時点
in
でど
order
ん
to
な課
achieve
題
mass
を認
production.
識
What
し
are
てい
the
るのかと
possible
いうあたり
challenges and
と、
issues you
あ
are
とは
aware
そ
of
の実現し
to
た
achieve the
先
mass
ですね、
production?
その
After mass
出てた
production
全
is
固体電池
achieved,
について、その
as to the
エネ
all
ルギー
solid
密度とし
state
ては
battery, what
ど
is
れ
the
ぐらいを
energy
想定してい
density?
るの
What
か、
is the
そのあたり
desirable
を伺えてい
energy
るとありがたい
density
で
that
す。
you
よろ
like
しく
to
お願いしま
achieve
す。
eventually?
これ
Thank you.
海田の方から
Kaita would like to
回答
respond
申し上
to
げ
this
ます。
question.
ご質問ありがとうご
Thank
ざい
you
ます。
for your question.
まずですね、
First of all,
最初に後ろの方のエネルギー
initially,
密度につ
about
き
the
まして
energy
は、
density
まあ、テクニカルワークショ
specification.
ップでも
At the
解
technical
説させてい
workshop,
ただきま
we
すけれども、
responded
まあ、
to that
26
question,
年の
but
中に、
26
まあ、
of course,
新たな、
new BEV platform will be ready and then created, and then the current vehicle model can be improved, and the cruising range will be doubled and more. So that is the desired specification of the battery. So the initial all solid state to be produced, that the energy density should be increased by 20% or more. But all solid state battery, of course, is different from the liquid based the battery. So new breakthrough can be achieved, and a new advancement will be achieved. So the basic platform will be created by this new solid state battery. Ultimately, the further performance enhancement should be achieved, and there's a big potential to achieve that. And as of now, toward the mass production, I think there are certain barriers to achieve mass production. Maybe that's the gist of your question, as I touched upon earlier. But this is a brand new material, so the plant has to be scaled up. You have to play it by the year by looking at the demand level and increase the capacity. Scale up. It's a chemical plant, naturally. So Idemitsu is expert on this. But anyway, safety should be considered, and then the evenness of the material to be created should be verified at one step by step, so that gradually and steadily the scale up should be achieved. So that has to be ensured in 27 or 28. That is a target date for our challenge. So that's our challenge, or that's some of the requirements that we have in mind. I hope this answers your question. So what about the remote future challenge? Do you have additional challenging targets in the remote future? 27, 28 and afterwards? Because before 27, 28, if we scale up at certain desirable speed, we will achieve it. And then cost reduction is another factor. And we have to think of the process in the same material. Maybe a simpler process could achieve the same property. So we have to look at that scrutiny. That's one of the challenges. That is a cost reduction aspect. And the other aspect is that for the platform of this all solid state battery, of course, that platform should be enhanced in terms of its inherent performance, high energy density and lightweight, and then quick charging time and so forth. All those two the factors and challenges are something we have to keep in mind and tackle with. Thank you.
Thank you very much. Then the person on the third row. Yao from Nikkei. Thank you for the opportunity. I might have missed explanation, but earlier, when Kaita-san took the floor, the breakthrough by Toyota is supported by 3 technologies. If you can tell us once again, what are those 3 technologies, and if you can explain more in detail. At the time of June technical workshop, the breakthrough was referred to. Where you stand in terms of breakthrough, and what are the challenges that you're going to work on to achieve a breakthrough? Thank you very much, Mr. Yao. I'd like to respond to those questions. About the breakthrough or challenges that I mentioned is that, as Mr. Sato mentioned in his presentation, because it is solid, it has an advantage, but at the same time, then there could be a crack because it is solid, and once crack is produced, then ion path would be cut off. That will be a technical challenge that has to be overcome. To cope with that, inside the battery, the separator as well as cathode, anode, the positive as well as negative ions are there, and in between, or the active materials surrounded by solid electrolyte are the areas where we want to prevent generation of cracks. And talking about cracks, there could be different causes and characteristics. And there are 3 factors to it. And then adhesiveness, adhesion, and a solid electrolyte that should be flexible, and the resistance against the swelling or other constriction.
なってまいります。
Those are their
このブレイク
keys
スルー技術については、
to achieve a breakthrough.
現在地がどこにあるかという
And
こ
as
と
to
に
what
つ
we
きまして
stand
は、そういったで
in
す
the
ね、技術
process,
の基本的なところの目処は当
the
然ながら
fundamentals of those
ついたというよ
technologies,
う
of
な
course,
状況ですので、
are
27年から28年のチャレ
always
ンジということ
already
を申
within
し上
a
げている
region.
次
That
第
is why we have been
で、
saying
さらに
about
それを量産
26,
化に向けて、
27. And then
確実
beyond
に
that, for mass
やっていく
production,
27年から28年に出すというだけでもですね、
the commercialization in 27, 28 alone
ある
would
程度の
require
そのスケールアップをしていかないとい
the
けないので、それを
upscaling
確実にする
the
ということです。
technologies
で、今
that we
回
develop.
出光さんとこうやって協業しているということも
And
その一つでございます。
collaboration with
サプライチェーン
Idemitsu
をしっ
is
かり
one of the
と
ways to achieve that.
作っていかないとい
That
け
is
ない
to
で、
establish
それを確実に
solidly
やっていると
the
いうのが
supply
今
chain.
回の協業の
And
発表というふうになっているという
that
ふうに
culminated
お考えい
into
た
the
だければ
announcement
と
of
思います。
collaboration this time.
少し佐藤から補足をさせていた
Sato
だきたい
speaking,
と
I'd
思い
like
ま
to
す。今
make
海
some
田が申し
additional
上げたよう
comments.
に、
As
その
Mr.
全固体電
Kaita
池
just
のブレイクス
mentioned,
ルー、特に
the
耐久性
breakthrough
に
of
関
a
する課
solid
題
state,
をど
the
う乗り越える
battery,
かというとこ
especially
ろが非常に重要だ
durability
と思っていまして、
question, is
説
crucial
明
for
の
us.
中でも何度も出てきています
As was
出
mentioned
光さんの
again and
固体
again
電
in
解
the
質に
presentation
ついて
about the
は、
solid electrolyte
今
with
海田の言葉を借りれば、粘
Idemitsu,
り強い、柔らかい
according
素
to
製
a
で
Kaita, that is a kind of
生
flexible,
成することがで
resilient
きる
type
と、
of
こ
the
れ非常に大き
material.
なポイントであり
And
まして、
that's crucial
これまでもいろんな形で変形
because
抑制の手法という
conventionally
のは
we have
様
been
々
looking
議論
at
されているわ
the
けですが、
controlling,
柔ら
restraining
かく柔軟性の高
deformation,
い固体
but
電解質があ
flexible
るということは、
and
その変形
soft,
抑制の方法が変わる
solid
ということになります
electrolyte
ので、
means that we have
これ
to
は
introduce a
電
different way to
池
control
製品としての
deformation.
電池パックまで視野に入れたとき
So
に
we
は、
have to take into account the
その
battery
形
package
が間違いなく変わってくるという非常にブレイク
when
スルーテクノロジーだというふうに
the
思
with
い
the
ます。
breakthrough
これ
technology,
は
the form of
あ
the
る意
battery
味その
pack
材料の
could
入り
be
口から
different. In other words,
電
from
池の
the
製品というと
entrance
ころの出口まで
of the
を
material
両者
all
で
the
一
way
気通過
up
に
to
や
the
るからで
exit
きる生
of
まれ
the
るブレイクスル
a
ーであろう
battery.
かと思います。
That's a
今回
process
の協
that
業の
those
シナ
two
ジーは
companies
そ
are
うい
going
う
to
入り
work
口から出
together
口のと
to
ころまで
produce a
を
synergy
一
from
気
the
通過に
entrance
両者で
into
や
the
ることによっ
exit.
て得られるブレイ
By
クスルー
working
をいかに
together
スピード感を持って
during the whole
実現してい
process
くか、ここ
in a
に
speedy
あるんじゃない
fashion.
かなというふうに
And
思いま
that's
す。
what we are
これは
trying
ひ
to
いてはや
achieve.
はり
And
最終的
eventually,
には日本の
that
産業
would
国
lead
際競争
to
力を高めていくた
increasing
めの非常に重要な
the
スキル
industry
であろうと思います
competitiveness
の
in
で、
the
ある
international
意味企
market.
業間競争と
In a
いう
way,
視点よりは、
rather
国
than
際競争力をい
competitiveness
かに
among
高めてい
different
くか、
companies, it is
その
more
ためにこの
about
協業のスピードを
improving
上げて、
international competitive
一部
edge,
早く
and
も
therefore
の
we'd
に
like
し
to
ていき
speed
な
up
がら
the
改善を
collaboration
続けていく。
and then
ある意味
continue
材料か
Kaizen
ら
or improvement.
一気通貫でやるということの意味
So
は、
the
スピー
meaning
ドを上
of
げるという
starting
こ
from
と
the
もあるんです
material
が、
is
改
besides
善のための
speeding
原
up,
点に戻れる
it
という
is
ところに
also
メリットがあ
going
りま
back
す。
to the
何か不具合
original
が起きた
of
とき
the
に、そ
Kaizen,
の
that
不
is
具合を
whenever
会
there is
社
any
で法的に
failure
対処する
problem
んではなく
experienced,
て、
rather than
その
just
原因
working
ま
on
で
that
遡
particular
って
failure or
原点か
problem,
ら改
we
善
can
を
go
する
back
仕組
to
み
the
が組め
starting
るという
point
ことに
and
なりま
then
すので、
can
それ
redesign
はある意味
this whole
手戻りの
system
ない開発
so
をして
that
い
we
くと。
don't have
手
to go
戻りのない
back
開発
again and
が実は
again.
これは最終
And
的に
the
はスピード
development
を上げる
process
ということに
eventually
つな
that
がっ
would
てますの
lead
で、
to
そういった取り
accelerating
組みが
the
両者
production
によっ
process, the
て
development
これから
process. And
な
that's
されてい
what
くとい
two
うことを
companies
ぜ
are
ひ今日
going
お
to
伝
work
えしたいと
together.
いうことで、
And that's a
本
key
日会見をさせ
message
ていただ
that
い
I
ておりま
wanted
す
to
ので、
emphasize.
そういった点をご理解いただければというふうに
Hope
思いま
that you
す。
would
あり
kindly
がとうございます。
understand the
わかりま
key
した。ありがとうござい
message
ます
that I'd like to convey to you.
あ
Thank
り
you.
がとうござい
Understood.
ました。それではお時間の関係上
Thank you
質
very
疑応
much
答
for
をこちらで終
participation.
了させ
Since
てい
the
ただき
time
ま
is
す。も
getting
しご
short,
質
we'd
問
like to
がございま
adjourn
す。
this
記者の皆
session
様
for
は
question
両
and
者
answer.
広報部ま
If
で
you
お
have
問い合わせを
additional
お願いいた
questions,
しま
please
す。
refer to our
次に
communication
ポジションに
department
移りますが、
and
登壇
send
者
us
は準備の
questions
ため 一度
So
講
now
談
we
を
like
させ
to
てい
have
た
a
だ
group
き
photo
ます
session so that speakers will get
お願いいたします
down from this stage and they will now be ready for the photo session. Thank you.
お待たせいたしました。それではフォトセッションを開始させていただきます。登壇者4名、まずステージへお願いいたします。
はい、それではまず公式カメラマンから撮影をさせていただきます。はい、それではスチールのカメラマンさん、皆さん写真どうぞお撮りください。ちょっと左右広がってますので、まず右手の方、こちらの方にもお顔をお願いいたします。よろしいでしょうか。はい、では左手の方、お向きください。よろしいでしょうか。はい、続いてムービーの、はい、もう少し。それ後で2人の時にさせていただき。
4人バージョンのすみません。
よろしいでしょうか。はい、それでは、この後ムービーの撮影をさせていただきますので、皆さん一旦前にいらっしゃる方は少し頭を下げていただけますか、しゃがんでください。ではお願いいたします。先ほどと同じように、じゃあもう一度握手をしていただきますよ、4人で。はい、それでは、はい。はい、それでは4人での撮影はこれで終了させていただきます。この後社長2人の撮影となります。ではお二人どうぞ。では続きまして社長2人、まず公式カメラマンから撮影をさせていただきますので。はい、ではお二人固い握手をよろしくお願いします。ちょっと待ってくださいね。今公式の方でいいですか。はい。はい、では皆さん、あとスチールのカメラマン様、どうぞお撮りください。では少し向きを変えさせて、まだいいですか。それでは少し顔の向きを変えていただきましょうか。まずじゃあ左手の方からよろしくお願いします。いいですか？いいですか？はい、では続いて右側の方お願いいたします。紀藤さん、ちょっと顔が表情が硬いかもしれないです。 よろしいでしょうか。はい、それでは続いてムービーの方の撮影をさせていただきますので、皆さんちょっとしゃがんでください。ではまず正面を向いていただいて、はい、ではそこからでは握手をお願いいたします。よろしいでしょうか。はい、いいですか。はい、では、はい、じゃあ戻します。
カメラを、はい、では登壇者はここで講談させていただきます。ありがとうございました。以上をもちまして出光興産トヨタ自動車の共同記者会見を終了とさせていただきます。本日は長時間ご参加いただきまして誠にありがとうございました。